doing as a profession and things like that, what's the goal? What's the macro goal of all your research? Okay, so the entire goal of cyber security industry, the cyber, is that can we reduce the risk? What is the risk first of all, right? And then can we reduce the risk? Okay, so cyber risk is a likelihood of threats occurrence by a threat actor, resulting in adverse impact after exploiting a vulnerability. Now, it's a pretty loaded definition, so just don't worry about what are all the technical terms in that. Like say there's a threat, there's a threat actor, there is impact, there's vulnerability. So just don't worry about those definitions yet. I'll take ample time to explain in simple terms what these definitions are. And I'm sure most of you are aware of this, but there is always confusion because our industry does not have any well-defined taxonomy. People interchangeably use vulnerability with threat, with exploit, and things like that. So this talk is about setting the ground with proper definitions. I'll cover that as well. But at a high level, right? When we communicate risk, when we say there is high risk or low risk, right? It's something like these examples. There's a 90% likelihood of a cyber criminal exploiting a SQL injection on a website that might result in loss of data. Right? So when we communicate risk, it should be very, very crisp. People should understand it, and there should be some kind of authenticity or your calculation behind that, rather than saying, hey, your website might get breached, or there is a high likelihood of exploit. Right? So we try to jargonize that a bit and give more concretized numbers as much as possible when we talk about cyber risk. Another example could be there's an estimated 10 million likely loss of revenue for your organization if an employee steals particular intellectual property from a file server over the next 1 year, right? Rather than saying that, hey, if we lose this file, then there is going to be a loss of revenue. Or it could be downtime. I mean, there is an estimated 12 hours of downtime due to an untrained employee clicking on a phishing email, resulting in disruption of operations. So, each of these statements, there is some kind of a precision in terms of whether it's accurate, not accurate. We'll come to those discussions and debate a little later. But at least we are communicating in precise numbers on what this risk is about, either in terms of a probability, or in terms of dollar value, or in terms of number of hours. Okay, we'll come to this discussion throughout this talk, and we'll see more examples as well. But at a high level, I'm trying to give you a feeler of what cyber risk is all about. Okay. Now, what cyber risk is not, what it is not also is important to understand. A mere existence of vulnerability doesn't mean cyber risk, right? Merely saying that, hey, there is a Log4j vulnerability on a server is not a risk yet. Okay, we need to understand a lot of parameters in terms of is that server switched on at least, right? Or is there an applications running on it? Is there any business impact if it is down? So a lot of parameters that needs to be evaluated before we even say that's a risk. Until then, it's just a vulnerability, absence of control. We can't just say that, hey, there is no edge firewall, or there is no cloud firewall, or there is no encryption. That's why it is risk. No, it is, again, very, very abstract statement. We can't just say that mere absence of a control is a cyber risk again, right? We'll cover these examples through presence of an indicator of compromise. You would have seen that, hey, this particular malware has this file hash or an IP address. It is a risk. No, as we have seen, cyber risk statements in the first slide. It should be more precise, more articulated, and the likely impact also to be articulated in that. And presence of a probable threat actor. We can't just say that, hey, this employee background check has failed. He has some past criminal history, so it's a risk. No, not yet. Right? It's highly unlikely or likely. We don't know unless we do some more analysis on that. Right? So these are some examples of what cyber risk is not about. It's very important to know what cyber risk is, what cyber risk is not. Okay. Now that I've set some basic ground on what it is and what it is not, let's understand what is risk intelligence, right? So this talk is all about cyber risk intelligence, the research problems and things like that. But before even we get to cyber risk intelligence, what is risk intelligence at all? Okay, so again, there are so many definitions. This is one that I found to be well articulated in a book called a book by the same name, Risk Intelligence by David Apgar. So it's very informally speaking, it's about how we weigh our risks. Okay, so risk intelligence refers to either an individual's or an organization's ability to weigh risks effectively. So this is a generalized definition of risk intelligence. It could be anything. It could be what is a risk of an earthquake, or what is the risk of a terror attack, or what is the risk of a pandemic. Right? Few years back, if you think pandemic, where everyone would have said, oh, there's a very likely a very low risk. No one would have predicted, despite there are some weak signals here and there. Right? So these are really hard problems, and you know the impact now of the pandemic. Now these are all general risks for either an individual or an organization, right? So it involves classifying, characterizing, and calculating threats. It's very important to understand this. Classifying, characterizing, and calculating threats. Perceiving the relationships, learning quickly, storing, retrieving, and acting upon this relevant information. So the whole point, the whole exercise of generating this risk intelligence is that it should help us calculate the risk, calculate the threat, understand its relationships within the organization, and it should help us quickly make decisions so that we can adjust to these new circumstances. Right? In a general sense, if we know that, hey, there is a wave 3 going on, you probably adjust your ways of the risk, and you weigh down, should I go, should I not go, should I go for shopping, should I go to eat, right? Maybe there is a more risk in this area, and so you start managing, you weighing the risks of stepping out or stepping not in general terms, right? So just adapt this to cyber. At the core of this is the ability to estimate the probabilities very accurately, at least as closely as possible. That's another definition by Dylan Evans, which communicates well. Okay. Now adapt this definition to cyber. We'll see some more examples down the line. Questions such as, should I patch this server? Questions such as, what is the estimated loss? Questions such as, am I doing better than our peers in the industry, or my organization should invest more in the cybersecurity? So these are the questions that risk intelligence, the cyber risk intelligence, should help answer for the decision makers. Okay. Now, what is it? How is the difference from threat intelligence? I'm sure many of you in the audience who are in the domain are familiar, at least familiar, or even working with the term cyber threat intelligence. What is it and how is it different? Okay. So when we talk about cyber threat intelligence, it's more tactical in nature. So if you all are familiar with the pyramid of pain prepared by David Bianco, it is about very clear, crisp indicators of compromise to help you identify a threat in your environment, right? So it could be hash values of malicious files. It could be IP addresses from where the malware is coming. It could be domain names where the malware is hosted or the beacon server is reaching out. It could be network or host artifacts. It could be PCAP files. And it could be tools or techniques and procedures, right? So the collection of all this information, the skills, the processes to collect the information, all this is related to cyber threat intelligence. Okay, it's a quite closely related field to risk intelligence, but not exactly the same. Okay, so in degrees of complexity, it's almost trivial to identify the hash values in your file logs. And as the degrees of complexity go up, the TTPs are very hard to find. But the entire goal of cyber threat intelligence is for detection and responding to an ongoing threat. Okay, but risk intelligence is not that. This is what threat intelligence does. Okay, so let's see. So is cyber risk intelligence and cyber threat intelligence complementary or orthogonal? Okay, so I would say they're complementary. Okay, but there are subtle differences again. Cyber risk intelligence is more of identifying the risk. Again, risk, not threat. I'll cover these definitions in just 2 more slides. Estimating the likely impact. The impact could be, as I said, in a probability. The impact could be dollar hours. The impact could be in downtime. It could be a very a concrete number to speak. Okay, and it helps in strategic decision making. Strategic decision making, as in how much I need to invest in cybersecurity. Should I upgrade my firewall? Should I buy a new data leak prevention tool? Or am I investing the right things? So these are all strategic decision making that helps the executives to invest it right in the cybersecurity. It's of course not only about investing it right, but there are other problems as well. But it's more strategic in nature. Whereas cyber threat intelligence is identifying the threat, mitigating an ongoing cyber attack. For example, there is a new zero-day vulnerability. You want to identify whether your environment has Log4j vulnerability in it, or a particular ransomware, a signal, I mean, a weak or a strong signals of ransomware artifacts, right? That's more tactical decision making. It's here and now, I should go and patch the server. It's here and now, I should go and push the WAF rule or IPS rule and such like, right? But soon we are going to see, when I start discussing the research problems, how cyber threat intelligence can aid in helping strategic decisions as well for cyber risk intelligence. Okay, so these two are separate topics, but they're quietly related and they go hand in hand. Okay, but we need to clearly understand what's the difference. So as I said, let's first, before getting into the research problems, I have introduced many terms: threat, vulnerability, risk, impact, control, a lot of terms that I have introduced. Unfortunately or fortunately, as I said, our industry has not well made these definitions mainline because of so many other factors. It is time we, as researchers, start adopting a particular taxonomy and clearly have definitions of what we're talking. Other ways where we cannot solve the problems. Okay, so what is a vulnerability? What is a threat? Let's quickly see some definitions and examples, then we go to the exciting part of the research problems. Okay, so what is a vulnerability? A vulnerability is a weakness in an information system, or the procedures, or the internal controls, configurations, or a particular implementation, right? It's a weakness. It by its own does not mean risk yet. Okay, examples could be, hey, this application doesn't have multi-factor authentication. Hey, there is no encryption, so somebody could steal the data, or whatever, right? Excessive privileges, or SQL injection, or a particular CVE saying that CVE 2018-1176 has such and such implications and things like that. These are still weaknesses, but not a risk yet. Okay, we'll see when it becomes a risk. Now, what is a threat? Okay, so this is a big mistake. Many of the literature, both industrial literature and academic literature, is that we use the terms vulnerability and threat interchangeably, but they're not. Okay, so for very good taxonomy or the repertoire of vulnerabilities and their classifications, I think most of you might be familiar with attack maitre, wherein you can see the common weakness enumeration, common vulnerability enumeration, these kind of definitions for subsequent reading. That gives a dictionary of all popular vulnerabilities, weakness enumerations, and things like that. There are some open problems even there, like there is no a common dictionary for misconfigurations. There used to be a project a couple of years ago called CCE, common configuration enumeration, but that's no longer supported. So there is a lot of work needs to be done even in preparing dictionaries of these misconfigurations and such like. Now, what is a threat? A threat is a circumstance or an event with potential to adversely impact organizational operations, assets, individuals through an information system. Right? That is a threat. Right? We are again talking in terms of cyber. Now, denial of service is a threat. For example, there is an e-commerce website and there's $1 billion sale, and the threat to that $1 billion sale could be a denial of service attack. We are not talking about how the attack will be happening. We are only talking about the likelihood or a circumstance, not even a likelihood, or a circumstance or an event that could impact that $1 billion sale. Ransomware, right? The threat on healthcare infrastructure during these pandemic times is ransomware. Okay, or phishing, or data breach, or espionage. So these are all threats. These are not vulnerabilities. These are threats. Okay. Now, for a complete taxonomy, a very good taxonomy of threats, there is a very good paper by ENISA, European Security Agency, which has this a very good list of threats and definitions and things like that. So, highly recommend going through the threat definitions. Okay. Now, threat actor. Now, who is an actor? Unless a person or an individual or group that can manifest this threat. Now, it could be a disgruntled employee. He's somehow upset for something. He just stole some data and sold it for a competitor, or he abused that information in some way that could cause harm to the organization's revenue or reputation. Okay, or it could be a seasoned cyber criminal, or it could be a competitor trying to steal intellectual property, or it could be a nation state actor. Right, nation state actor. There are a lot of accusations on, threat actor groups associated with some countries. Okay, or it could be a vendor. Right, maybe he's malicious in nature. Right, so these are all threat actors. Now, what is an impact? An impact on an organization, it could be in terms of financial or reputational losses. Okay, loss of productivity, revenue loss, cost of investigations, penalties, loss of brand reputation, and sometimes even human losses, right? In terms of, there are some early news, of course, it's still under trial and things like that. A hospital got ransomware attack, and they had to shift patient somewhere, and then unfortunately the patient eventually died. Now they're trying to investigate whether they can associate that with a cyber attack, right? Or car hacking, an automated car hacking. What if somebody remotely hacks your car, and there are a lot of demonstrations on how a car could be remotely hacked and things like that. What if there are human losses due to that? So the impact could be anything. Okay, so what is a control? Okay, a technical or non-technical information that exists to remediate and mitigate any potential impact. Okay, it's actually non-technical information asset. The asset is missing there. Examples could be an antivirus, a firewall, the SIEM. It could be even policies and procedures, or even security awareness trainings. These are controls, right? Now comes risk. Okay. Now you could think of risk is a function, in a mathematical term, function of the vulnerability, threat, impact, and control, right? Or in a plain English, you could say that cyber risk is a likelihood of threat's occurrence by a threat actor, resulting in adverse impact after exploiting a vulnerability. So it has everything in it. So there should be a vulnerability, there should be somebody exploiting it, that somebody is the threat actor, of course, and that should result in a threat. Okay, but cyber risk is almost always pre-ante. I mean, before the fact, before it happens, we're trying to come up with some estimates, likelihoods, probabilities, dollar values, and things like that. So it's not post-ante. It means it's not after the fact of an attack, but it is prior to the attack. So this helps minimize the losses. Okay, if we have near accurate, I'm careful in choosing the word accurate, because there is simply no way to accurately predict it. We can only be as close as possible. If there is near accurate way of calculating this risk, then we can, of course, act upon it, take a decision, mitigate it, remediate it, and things like that. So that's the difference. You could think of a risk is a forecast. Okay, something that we are leaping into the future and saying, based on the data available, the circumstances, the ongoing threats, and numerous other factors. Okay, so these are the definitions of the terms that I'm going to use in the subsequent rest of the talk. Now it's going to get interesting. Okay, so let's revisit the cyber risk intelligence examples that we have. Okay, we said these are all, by the way, risk statements, examples, risk statements. So a 90% likelihood of cyber criminal exploiting a SQL injection, or estimated 10 million likely loss, or estimated 12 hours downtime, right? What do you notice? What did you notice in the above examples? I'll take a brief pause here. If somebody would like to answer, just feel free to unmute yourselves and answer. Right? What did you notice in these above examples? Unfortunately, I can't see the chat window or anything if you're typing, but yeah. Any answers from anyone? What did you notice? What is the subtle thing that you have noticed in all these three risk statements? Anybody? Hello? Not sure. Am I audible?
Yes, Sashank.
Okay. So no worries. So let me continue. Okay, let me explain you what is that we should be looking for here, right? In almost all these
Weak
statements.
database.
Sorry. Was there an answer?
Or weak website.
Okay. And what else you have noticed? Okay. Let me answer. Okay. So
Lack of security awareness.
okay, security awareness for the phishing thing. Okay, good. And then okay. Okay, then let me answer. Okay. In almost all of these three statements, we're talking about an attack, an impact that might happen in coming time. It has not yet happened, right? If you see here, we are telling to some level of accuracy that 90% likelihood, estimated 10 million, estimated 12 hours downtime, right? So that's the key term here when it comes to risk statements. Okay, we are not saying that, hey, there's a high likelihood. We're not saying that there is huge revenue losses. We're not saying that there is a huge downtime. No. Okay, to some level of accuracy, or to coming up with some numbers to articulate the risk. Okay, let me go ahead. I know this is an emerging field. It might be a little bit confusing as well, but let me articulate in subsequent slides on what the research problems are and how how fascinating this area is. Like how can we say the likelihood of something? How can we say the estimated loss of something? Right? How do you even estimate such things? Okay, so these are the research problems I could think of in this particular area. There's a very nascent field. There's a lot of work to be done, a lot of exciting problems to be solved. I'll cover each and every problem with examples and with one or two of the latest research. So this talk by no means meant to be an exhaustive coverage of state of art or something like that, but this talk is meant to be providing motivational examples, providing some recent papers that are exciting ways of solving these and such like. Okay, probably there's a if some of you researchers in the audience, or if you know somebody, probably we could work on articulating this as a position paper or something like that if you want to pursue a research in these problems, right? So let me come walk you through each of these problems. Then let's see what these problems are about. Okay, so the first, before even we get into the problems, for almost all of the solution direction, right? I'm not saying solution because they're not, at least there are no mature solutions yet. There are some only solution directions. For almost all of them, the solution direction would be something like this, wherein we have a lot of this publicly available or privately available data input. It could be vulnerability databases, security advisories, hacker news, threat forecasts. There are a lot of reports, right? And then we come up, depending upon the use case and the research problem, we come up with the necessary machine learning algorithms for that. It could be NLP, it could be neural networks, it could be whatever, right? So we'll come to the solutions on how people are trying to solve it, and the outcome should result in some kind of risk factors that can help solve one of these research problems. Okay, so this is the underlying pattern. So if you're looking for some good data science problems, if you're looking for good decision science problems, there are ample scope here from a machine learning perspective as well, to apply and solve, probably file some patents, publish some papers. There's a lot can be done here. Okay, so the first research problem is risk contextualization. Okay, so what do we mean by contextualization? What are the questions? What are the sub problems, or what are the questions that risk contextualization research problem tries to solve? Okay, let's understand the context a bit. Okay, there is almost always, whoever has subscribed or reading all these news articles, research papers, security advisories on a daily basis. If your day job is to safeguard your organization, or if your day job is to protect your organization and understand, what kind of malwares that are coming, and things like that, context is very, very important, right? So the two primary questions, as in, is this malware, right? You can replace the dollar malware. I mean, I meant it to be a variable, right? We are all programmers and researchers and things like that. So you can replace it with any malware out there. Is this particular malware which I'm reading about going to impact my organization? That's the first question, right? I read about Log4j, or I read about, that's not a malware, by the way, it's just a vulnerability. I read about, whatever is the latest malware, right? Or a ransomware attack. Does it going to be, that's going to impact my organization? Then the second question, a similar question, is there are a lot of security advisories being released. A certain computer emergency response team of different countries, different industrial collaborations, or the vendors, for example, Microsoft, Google, Amazon, any of the major vendors, they keep releasing these advisories, security advisories, saying that, hey, such and such product of ours has a vulnerability, it has a patch yet, no patch yet, whatever. We'll see some examples. Even in this scenario, the first question comes to us is that, hey, is this relevant for my organization so that I can safeguard my organization's assets, right? So let's see some example. So this is some sample news article which has come a while ago, which talks about that there's a bank in Bangladesh that lost some 80 million because there was a fraudulent Swift messages. Somebody hacked into their Swift core network. Somebody trojanized their PDF software, and the threat actor is Lazarus Group, and so on and so forth, right? Now there are hundreds and thousands of these news articles coming all the time, right? It's simply not feasible for me as a security administrator or a CISO of my organization to go over them and then digest all that information, contextualize it, and understand, right? So if only there are better ways, as an example, if only there are better ways of translating these text security advice, these are news articles into something more concrete, like a risk instance. If here you could see that the central bank is an organization, Bangladesh is a country, financial services is an industry type, ban Swift is a malware, right? So if only we can use any of these latest and greatest AI/ML techniques in order to translate them into concrete risk instances, subsequently we can do a lot of analysis, filtering out based on the industries that I'm interested in or the organizations that I'm interested in, that the news feeds can be contextualized for my environment. That will be of huge, immense help. Okay, now you could, I mean, some of you in the audience who are data science oriented or experts in the field, you could start thinking of, hey, I should be using named entity recognition, or I should be using some other algorithm or this algorithm, but operationalizing whole of that, getting some good efficacy results is still work in progress. I would say there are very few early commercial products out there, and there is a lot of research to be done. Okay, so the second example from contextualization perspective, you could see that this was a sample example posted on one of the Google's bulletins. It says that hey, there's a potential denial of service in some protobuf Java library, and it has a particular CVE, and you should go and probably patch it. Right? By reading this alone, yeah, sure.
So can you kindly give some examples of the sources from where we can collect the input? Like for example, you said like
Sure.
hacker news. Other than that, like from where we can derive risk, like can you?
Yeah. So, Vinod, what I will do is because we have a laundry list of the data sources, probably post this call I can give.
Sure.
Okay. So there are a lot of, I mean, by the way, data is no longer the problem. Availability or lack of availability is no longer the problem. There are a lot of good sources out there. There are a lot of good ML models can be built out of it, right? So I'll probably as a follow-up of this, I can share you some of the data sources that I'm tracking myself, or pointers to the data sources where you can track it yourself as well. Okay.
Sure. Okay.
Yeah. Security advisories, as I was talking about, again, can be almost every major vendor has these security advisories. Okay, just Google for cybersecurity advisories. Then almost my first 2 pages of Google results were Microsoft, Google, Amazon, GitHub, Atlassian. You could think of all major vendors, Cisco. There are so many, right? And almost all of them have these RSS feeds. RSS is a technology where you can subscribe to it and continuously get these feeds, and then build parsers and then run it through your models and things like that. Okay, so that is the power of contextualization. That's the first problem of contextualization. Okay, so now you get it. So what are the challenges? The challenges are here, as I said, the ML models, the NLP techniques for the named entity recognition, or any of the ML models. I'm not that much of an ML expert, but what I could say with my because I'm coming more from a practitioner come security researcher come risk researcher perspective. So what I can say is that the field is very nascent, and there's a long way to go before we can even have a well models for contextualization of all these news articles and security advisories. Okay. So the next interesting problem, okay, correlation. So what is correlation? Okay, what are the problem statements in risk correlation? Okay, so let's quickly look into that. So correlation is about, okay, I have read about denial of service in the news, but I also read about log4j. But does log4j pose denial of service, or log4j poses remote code execution, or what is the threat from this particular vulnerability posed? Now, some of these advisories might be giving in for popular vulnerabilities like for log4j, but what about the 1 million or so? Not really. I think last I checked was some 1 lakh odd CVEs, and of course there are so many other misconfigurations. What is the threat posed by that? For example, you could say that, hey, SQL injection poses data loss. But what will happen during clickjacking? What will happen during if some security headers are missing? What will happen with any such vulnerability? Is there a systematic or a scientific way to tell that this particular vulnerability poses the threat? That's the correlation. That's of huge value for practitioners. Okay, huge value because I can prioritize based on that. The threat is not Same for all industries. If you are running a factory, like a manufacturing industry, then loss of productivity is very, very important for you. Okay. Then you want to identify which all are the threats that could impact your productivity. Denial of service becomes extremely important for you. Denial of service threat impact very important for you. So you may want to prioritize the vulnerabilities that cause denial of service, right? And if you are a startup, if you have a lot of intellectual property, as in some proprietary source code that's worth of millions of dollars, or you're working in pharmaceutical industry, right? Where whatever the medicine research that you're doing is of high value. Okay, then the threat again is loss of intellectual property. How do you say if data loss is, or the code loss or whatever, right? The threat of data loss becomes of high importance for you. So that's why correlation is very, very important, right? What type of TTPs does the threat actor use to exploit this vulnerability? This is slightly little bit lower layer than the first question, but still helps you to take decisions. What are the techniques, tactics, and procedures that a threat actor uses to exploit while exploiting this vulnerability? Will the threat actor laterally move in my network? Will the threat actor fool the user if there is this vulnerability in clicking some link, right? So this is another very, very important question. The third question is, what type of mitigations are effective against this threat? Okay, I found that denial of service is my highest threat. Now, what kind of mitigations should I deploy a WAF? Should I go and fix my source code? Should I purchase some anti-DDoS solution? Okay, so correlation across all these things. So I'm not sure how many of you recollect, but one of the early definitions that we have set is for the risk intelligence is that observing these relations or establishing these relations across these domain elements, like say threat actor, and vulnerability and control, right? So the correlation is very, very important and immensely useful for safeguarding your organizations when you're defending your networks and things like that, right? So let's see some examples. So this is a very beautiful paper that has come called Braun. So what they've done is they've taken these attack MITRE TTPs, then they kind of mapped with CWEs, then they further mapped it with vulnerabilities so that they can derive the affected product configuration. So it's a very, very beautiful way of building bidirectional graphs and doing some cool graph algorithms there, and then deriving, right? So for example, in one of the examples that I can make the slides available, no worries. But in one of the example, they mentioned that from the top list of 10 most exploited CVEs, they could identify attack patterns, tactics, techniques that exploit these CVEs, and also uncover a disparity in how much linked information exists for each of these CVEs. That's a very, very powerful information, very, very useful information if we can foster research in this direction, right? So otherwise, there were silos of information. Attack MITRE TTPs are hugely popular. Of course, there are works in progress where attack MITRE is being mapped to other taxonomies, but that's still, I would say, a work in progress. And if there is a smart way, if there is a better way of establishing these relations and then deriving new insights out of that relations, it will be hugely valuable. Okay, so as I said, like this talk is by no way meant to be an exhaustive survey or anything. It is just a dip check or a kind of thing saying that, hey, these are the problems, these are the kind of research papers that have come recently. There could be better research papers as well, but what I'm trying to cover is what comes in my radar. As I said, like if somebody is interested to a postdoc or a PhD in these areas, just feel free to reach out to me. I can provide some advice on any of these subproblems as well. Okay, so there is another interesting paper that's recently posted by Center for Threat Informed Defense is that they took this attack tray and tried to come up with ML techniques to map it to various databases. So one of the most comprehensive way of articulating or describing cybersecurity incidents that has happened already is various database, that is vocabulary of event recording and incident sharing. Almost all this data is there on GitHub in some spreadsheet formats and things like that. You are free to download and play around with the data. And Verizon comes up with a very good reports each year based on the data that gets recorded here. Now, what these researchers have done is that they took it to a whole new level, which are otherwise silos of information. For example, we have this attack tray talking about TTPs, but there was no way simply to link these TTPs with the incidents that already has happened. So the researchers have come up with ways of mapping and translating these two so that we get new insights in terms of what kind of TTPs can result in what kind of cybersecurity incidents. So they're very, very, very interesting. So again, the link is here, the source link is here. Just feel free to Google around for these projects. Poke around nearby areas. There's a lot of interesting stuff happening here. Okay, this is with respect to correlation. Now, prediction, right? As I said, if you observe some of my early statements, risk is always about preventing it before it happens, than afterthought. Okay, so one of the problems that comes is, can we predict? Okay, predict what? Okay, so there are some problems of it I'll quickly cover. There are again very, very fascinating problems here from a risk prediction perspective. But what do you predict, right? Do you predict the next log4j kind of a zero-day exploit? Why not, right? Can we predict whether an exploit will be built for this vulnerability, right? Why not? Some of the research papers, very exciting papers that I'll share in the next 2 slides, is about, hey, there is this new vulnerability out there, and how likely is that somebody is going to build an exploit for it? Because without an exploit, vulnerability doesn't make any sense. Vulnerability is just a vulnerability, right? Somebody should be able to build an exploit and exploit it. Only then it can start looking like a risk, not yet a risk. Okay, so these are 2 interesting questions. There is again ample scope here for research. There are a lot of good papers coming out here, right? So the first kind of a mature model is I mean, not really, but it's been there for a while. Mature among the ones that are there, but there's a long way to go. Is the exploit prediction scoring system. It is there on first.org as well. So they are trying to build this prediction scoring system where they collect all these open data sources available and predict whether the software vulnerabilities will be exploited. So the result of this analysis is a simple probability of 0 to 1. 1 means there is a very high likelihood that somebody is going to somebody is going to build an exploit for this vulnerability. 0 means it's very, very unlikely that somebody will build an exploit for this. So this, again, this kind of exploit prediction is also found to be useful in higher order problems like, say, prioritization and things like that, which I'll cover a little later. But this is another fascinating problem. Okay, now a little bit extensions of it, and another fascinating work very recently appeared in this direction is the expected exploitability. So this is someone's PhD research. Names escaping my memory. I'm really sorry about that. But the expected exploitability is an academic research performed at Maryland Cybersecurity Center and, of course, the SEF Com Lab, wherein they come up with this app. You all can go to this app. They're building similar models which gets continuously reassessed every day, wherein they calculate the likelihood of somebody building an exploit. So below, you could see an example. I just took a screenshot like last night of these CVs that got published. and then they are predicting whether somebody has built an exploit or not. Of course, there are ample ways of cross-checking whether these predictions are correct or not as well, because of late most of these exploits are made available by researchers on GitHub, Twitter, GitLab, and many other public sources. So it's easy to cross-validate, relatively easy, I would say, not really easy, but relatively easy to cross-validate whether there is a CVE and an exploit. So there is a fun experiment I was trying to do. As soon as Log4j CVE was announced, I think 2 days or 3 days, second day or third day when it was out, then when the numbers and all were available, I was playing around the EPSS module to see what would be the prediction, and the prediction was very good in terms of 0.8% or something. Sorry, not 0.8%, 84%. I mean, I was telling more from a probability of 0 to 1, 0.8 or something, roughly 84%. It was predicting that the model was predicting that there will be a high likelihood of an exploit. And as they have predicted, in the next few days, there are tons and tons of exploits that were made available. Okay, so very fascinating area again. Okay, so what are the challenges again? There are, of course, in all of these problems that I'm discussing, there are numerous challenges as well in terms of some I'll be explicitly covering also. So these models are all for CVEs where the vulnerabilities are well defined. The CVE ID is there, the CVSS vector is there. There's a lot of literature and things like that, but there's not much models for misconfigurations, right? You can have a website misconfiguration like security header missing, and there is an exploit prediction system for that. There are not models yet for those kind of misconfigurations because they're very subjective, but that's make the problems challenging, right? Whether you can build an exploit on a particular website for a misconfiguration of lack of a particular header is way different from the same missing header on a different website, because the context will be different. The defenses might be different, and there are a lot of other factors that we need to consider in order to predict an exploit on that particular stuff. So there's again a very fascinating problem. So yeah, so from an algorithms perspective, as I was mentioning, there are a lot of the security advisories. You can experiment with the NLP techniques and prediction modeling in order to come up with this predictive scores. Okay, so moving on, research problem 4 is benchmarking. Okay, this is slightly closer to my heart because the problem and the solution aligns with my PhD research as well. I'll cover what those are in a while. Okay, so what is benchmarking all about? Okay, so these are very simple questions looks like, but very tough problems to solve. Are we doing better than our peers? Like, for example, if I am a CISO of an organization, I would like to know in my industry type, for example, if I am a CISO of SBI Bank, right? I would like to know what other banks are. I would like to benchmark myself against my peers, right? How are other banks doing? Are we investing enough? Are we doing enough? Are we not doing enough? So these kind of questions, almost you can talk. These are all again based on our first-hand experiences talking to many of the CISOs and CIOs in the field, because that's what in our day job we do as practitioners and things like that. This question almost comes in every conversation. Is there a way for me to know, am I above the industry average on some metric, right? Or am I below? Should I invest more? Should I invest less? And such questions, right? So what are the challenges for this kind of a question, right? Almost every one of them wanted to this kind of a benchmark report, but when it comes to sharing the information, they're not quite ready. For example, what is I'll take a very simple example. What is your average patch compliance rate? Just making up an example on the fly, right? Let's say 80% of the time all your machines are patched. Whether industry average is 74% or 68%. But in order to benchmark it against the industry average, are we ready to share these metrics ourselves, right? So many were not ready. We could try anonymous surveys and things like that, but the technique of benchmarking it in a privacy preserving way is not that mature. So there are a bunch of researchers again from MIT. This is one of the paper that has appeared last summer, I believe, 2020, where they built a platform for securely measuring the cyber risk without disclosing the sensitive data. Okay, so they took this CIS benchmarks, the Center for Internet of Security benchmarks, the 20 odd domains, subdomains, and categories. They asked the CISOs or of different industry types to fill them up, but they need not share the information in plain text. They had to encrypt it with some sophisticated crypto algorithm so that they're not revealing their sensitive data. But the researchers could correlate, aggregate, and compute the averages and things like that on the encrypted data. So that way, the privacy of the input is preserved, but still they'll be able to get some benchmark measurement out of it. So that's very, very interesting. So that's where my PhD area as well, in terms of the privacy preserving computations and such like. Okay, so this paper fuses both my current work and my PhD research. That's why it's kind of close to my heart as well. But what are the challenges again? So there is a lot of so the researchers took a simplistic model to start with in terms of the CIS benchmarks, and then come up with ways of benchmarking it. But there's a lot of things to be done when it comes to doing some advanced analytics in a privacy preserving way. So there is a lot of technology that we need to build or invent yet, in terms of how do we encapsulate the organizational context or the asset context. How do we collect this data in a privacy preserving way? How do we build a computation on encrypted data technology? It could be multi-party computation. It could be homomorphic encryption. How do we apply these techniques on the data to derive the metrics that everyone is interested in, right? So very, very cool area again. So risk prioritization. This is the stuff that we are working in our startup as well, in terms of how do we prioritize the risk. Now, what do we mean by prioritizing the risk, or what do we mean by what is that we should be prioritizing, right? So let's see the problem statements for that. When it comes to risk prioritization, simple questions, as I said. So most of the research problems that I'm talking about are quite simple problems, but very, very difficult solutions that, very, very, very difficult to solve and come up with elegant solutions, effective solutions, right? So when it comes to prioritization, which among these vulnerabilities should I remediate first, right? The first question when the Log4j, I'm just taking the Log4j example all over because that's the most recent one and people could relate to it. When the Log4j announced, when the researchers announced that they found this Log4j and it started making news, the first question from the executive level people was the questions that I have answered, that I have posed before. What is the impact? Is my organization impacted? What does it mean to me and my organization and such like, from executive level, CISO, CIO's level. But from the IT managers level, from the security administrators level, from the people who are firefighting it level, their question was in which of my current 10,000 vulnerabilities should I go after first? Should I drop everything and go to Log4j? Should I prioritize it accordingly? How do I stack rank them? How do I come up with a way that gives better return on investment for for my already outstanding vulnerabilities, right? The second question of prioritization is at a little bit higher order in terms of which of these servers or which of these firewalls that I should be patching first, right? So if we have a more scientific way of prioritizing the vulnerabilities or the assets, that would be of immense help for the IT administrator as well. This is where the risk intelligence helping the tactical decisions as well. Okay, so tactical decisions as in day-to-day operations as well. Now, again, there are some open source, publicly available ways. Of course, I'm not covering the trivial ones like CVS scoring system and things like that. I'm assuming that most of you are familiar with it. I'm just handpicking few that looked interesting. So Valristics, there is this researcher, Leonov from Russia. He is very knowledgeable and posts a lot of good information on the vulnerability management and things like that. So he built this little tool called Valristics. That's vulnerability and heuristics. So, and each time Microsoft advisory gets released every Tuesday or so, he calculates the score based on his heuristics algorithms, not the CVS score, and comes up with that. So there's a very interesting way of how he applied heuristics on the vulnerability. He processes all these security advisories and things like that. Right? This is one you can just go ahead and read. It's there for a while. I hope the Valristics models itself are becoming mature now. Now, another way which I'm very fond of is a very proven technique in other domains called analytic hierarchical processing, AHP technique. It's a very good decision-making tool in order to come up with scoring and ranking and telling that which one to go after. So you could see that the vulnerability score, if you're trying to prioritize your vulnerabilities, then vulnerability factors are only a couple of them, whether there is an exploit or whether there is a malware. But there is a lot of other factors you need to consider in order to prioritize the vulnerability in your organization's context. So Valristics, or whatever is this name, I don't know how to pronounce that, but going by the name, Valristics does not take your organization context. It's purely based on the vulnerability, impact, and exploit and such like. But you need more comprehensive techniques that encompasses other factors like what is the impact of this vulnerability, what is your organization context, and then come up with some kind of risk score. Okay, so we have developed some cool stuff in our organization as well here in order to help our customers to prioritize their vulnerabilities. So there are a lot of challenges again here. It's not that it's done deal. The models are always evolving. We are trying to do our best job here with the given technology. In terms of how do you again establish the context? What kind of algorithms? How do you model the risk? How do you calculate these probabilities? And more importantly, how do you aggregate these risks? It's not easy to aggregate the risks at asset level or a business unit level or an organization level. So you have calculated the risk of a particular vulnerability, but how do you say what is the risk of your asset on which there are 100 other vulnerabilities? Do you simply take average? Do you come up with advanced conditional probability based approaches? So those are all the problems that we need to solve, right? And very interesting way is that there is this US chamber because and the moment people find it useful, there are simply so many risk ratings, security ratings, both commercial, non-commercial, has evolved for the sake of restricting my talk to a purely an academic and a research talk. I don't want to take names of any vendors and things like that who are having the security ratings, but you can just Google around that. But the problem with those kind of ratings is that it's very difficult to articulate, accurate, and compare. So that's when the US Chamber has come up with a few principles of for building these security rating algorithms. They emphasize the need for having a transparent rating system. Accuracy is of important because somebody is going to take decision based on your rating. Right? If you say that hey, this vulnerability is 90 out of 100, the IT administrator is going to believe in you, trust in your algorithm, and go and patch it first rather than the other one, right? So that's the reason why accuracy and validation of these models is important. Model governance, the modeling, the models that you build, governance of it, how often you are updating these models, how often you are evolving these models, and how independent these models are without getting too much influenced by various other factors. So these are some principles laid by the US Chamber, and it's very important when you folks, any one of you are working on the risk prioritization challenges to keep these principles in mind so that they're more useful and such like. Okay. So next problem is risk quantification. Okay. So some of the examples, some of the concrete examples that I have shown you in the beginning is an estimate of $10 million or an estimate of 12 hours downtime, right? So it all boils down to, can we put a dollar value so that the technical decision of whether to buy the latest firewall or to buy or to upgrade our existing endpoint detection systems is no longer a technical decision, but a business decision. Okay, so the moment you convert it into a dollar value of some sort, it's easier for CISOs and the CIOs to talk to their bosses, the CEOs or the board members, to get their budgets. So the quantification is important in terms of what are the likely losses to my organization if we don't remediate this risk, right? So what if we don't purchase that latest and greatest DLP software, the data leak prevention software? What are the likely losses, right? If we can have an estimate saying that, hey, there's a 10 million likely loss, but we just need to spend 100,000 on purchasing this DLP, that might make sense. That might be a business decision for the CEOs and board members to allocate the right budgets. But coming up with that number, how do you come up with a number which is reasonably close, saying that there is a likely loss of 10 million, right? It's not a simple problem. Again, there is a lot of work going on. And how do you justify your cybersecurity budget? Like, imagine you're a CISO or the CIO, and you have a 1 million budget needs, and you go asking for such a budget in the board meeting, right? How do you even justify that, right? So these are very, very important questions again that needs a lot of bringing in a lot of rigor in terms of estimating, a lot of principles from economics, a lot of research needs to be done and things like that. So what we have right now, the most popular one, it's called the FAIR model, factor analysis of information risk, which again, I don't want to go deeper into what the FAIR model is and how they calculate these estimations and things like that. But there's a very, very important and an interesting model to understand. There are many other models as well, but this has gained a lot of popularity in recent times, right? And there are challenges aplenty. Again, how do we automate it? This is a very manual and human intensive task to come up with the risk models, because the context changes for each organization and each risk scenario. So first we need to have risk scenarios, a catalog of risk scenarios that are publicly accepted, and then quantify those. And then of course there is a lot of modeling that needs to be done from a probabilities, calculating the probabilities and things like that, and automating it, right? It's not easy to automate these kind of calculations that are suitable for wider audience, because these are tailor-made for each organizations and each organization context. There's a lot of work to be done here as well. And in any of these models, a recurring theme I could see is that whether it is the risk, the exploit prediction, whether it is risk quantification, the challenge I see is that these models are not yet time tested in terms of, let's say this year you have predicted a 10 million likely loss, right? So can we go back? So let's say last year we have predicted 10 million likely loss. And this year again, I as a CISO or a CIO should go to my board and ask my budget. Can we both go back in time and say, hey, last year's my estimate was reasonably correct in terms of was my risk estimate close? Did we, is it 50% away? Is it 25% away? Is it 100% grossly wrong? Right? So these kind of problems are there. Still, we need to come up with models that are reasonably accurate, and we can validate these models over a period of time and such like. So very, very fascinating field again. There's a lot of work to be done. Okay. So the last research problem, the seventh research problem I could think of in this area is the risk remediation. So all that we have done so far, right? The entire, as I was mentioning in my starting remarks, it's all about what is the risk? Is it big enough in some sense, big in some sense of some number? How do I remediate or mitigate that risk, right? So when it comes to remediation, see, the whole point of this exercise is that we would like to reduce the risk. Now, how do I reduce the mean time to remediate? Automation? Yeah, that looks to be a no-brainer to do automate, but there are a lot of challenges even in that. And other questions as in which controls are most effective, right? Is it effective? Let's say we have found out SQL injection vulnerability. Okay, is it effective? Again, effective is a subjective term. Given my time as an IT administrator, given my resources, is it effective to go and block it in the WAF, or go and tell the engineering team to go and fix that SQL injection in the source code? What is effective? What is that I should do now? What is that I should do later? Which is like, what is that I can do to mitigate? What is that I can do to remediate? Right? So these are the questions this research problem tries to address. Now, let's understand a very, very simple model right now, how the risk is being either mitigated or remediated. So there is this concept called as OODA loops. Some of you might be familiar with it, but let me quickly explain it to you. So roughly, it is something like this, right? So the IT administrators try to observe some of these vulnerabilities through scanners and things like that. Then they want to filter out in terms of orient these vulnerabilities on the assets that matter to them. It could be production servers, it could be customer databases, it could be externally facing systems, right? And then decide, then they have to take a call, right? Should I remediate them, that is patch these servers or fix the code? Should I mitigate them by pushing a WAF rule or an IPS rule, and then act upon it, right? And this goes on. This is like a loop that keeps repeating itself for every type of vulnerability that can pose a risk to the organization, right? The acting can be, is there a way to go and auto fix it? Or should I raise a ticket that actually the IT administrator would go and patch the server, or the developer should go and fix that vulnerability in the code, right? So this is a very simplistic model of addressing the vulnerabilities that are of high risk in some sense, right? So traditionally, OODA loops are applied in threat hunting in terms of identifying the threat artifacts, detecting them in the logs, and then remediating them in some sense using the SIEM or the SOAR platforms of late. But what we need to go towards as an industry is shifting left this OODA loop, because detecting and remediating is little later in the cycle. But if we can shift this loop to identify and protect, right? If we can say we identify these vulnerabilities and protect the assets in earlier cycles, then the remediation, the mean time to remediation, comes down much smaller. This we have found it very, very effective in some of the environments that we're working as well. So, but how do we get there? How do we get to a situation where we identify the vulnerability and push a WAF rule rather than identify a bot that is exploiting this vulnerability from the WAF logs to responding it? right? That's a little later in the cycle. So there are numerous challenges again here from a remediation perspective. There are complex workflows, diverse defenses. On an average, at least a large organization deploys 40 security products based on some survey. Imagine, okay, between the number can be anywhere between I think 6 to 40 or 8 to 40 if I recollect right. Okay, there are firewalls, there are IPS rules, there are WAFs, there are encryption technology, there are key management services, there are at least, and there are wide variety of defenses as well. So which is the best solution that they need to go and fix? And not almost all of them have APIs and integration possible. Automation is not realistic always, right? As an industry, probably we should, as researchers, probably we should come up with more ways of bringing all these things together. And more important, once the remediation is done, how do you even validate it, right? So automatic verification is not always practical again. Okay, so there is a lot of complexities because the attack paths are diverse as well. So with this, I end my talk on the challenges. So to conclude, cyber risk intelligence is an emerging field with a lot of fascinating problems. This definitely helps data-backed decision making. Fascinating research problems are there, which we have discussed, and there's a lot of exciting road ahead. Okay, so that's my conclusion. Thank you everyone for patient listening. Hope all of you found it interesting and useful as well. We'll be glad to take any questions that you have.
Participants, if there are any questions, you can type in the chat window, or you can directly unmute and then you can talk to Dr. Sashank.
Good morning, sir.
Good morning.
How can we derive the tactics from textual data, sir?
Yeah, so what we need first is a comprehensive taxonomy of the tactics. So attack matter is one good source there. And another thing, I mean, of course, from the normal text, so sometimes what happens is, as a researchers, right, we may think that we may need some advanced techniques like NLP and things like that. But what I've found is, in predominant cases, right, the simple regular expression matching gives decent results to start with. That eliminates, that reduces your problem space in order to identify the tactics. Okay, but then of course you need advanced NLP techniques to understand the context, because when you have this text, right, you need to also understand the source of this text. Is it a journalist, a tech journalist writing a blog, or is it an academic researcher trying to write a research paper describing his technique, right? Because the English or the language sentences constructed will be different. So building the context out of that will be different. So what I would do, at least what we're trying to do, is that trying to segment the sources and then building custom models for each of it, right? So research papers, if you are translating text to techniques, you need to have models that are very custom for that kind of language jargon that is written, versus publicly available news articles. You need a custom models to be trained and derived. Hope that helps answer the question.
Good morning, sir.
Okay, one more question, sir.
Yeah.
Is there any benchmark data source available so that we can understand these TTPs?
To best of my knowledge, no, not that I could recollect of. Okay. Benchmarks, I see where you're coming from in terms of you want to say this is the research done, these are the results, the false positive rate or the false negative rate with these models, and this is what we have arrived at. But not that I come across. Again, as I said, like I'm not a very keen or active from an academic sense, because I'm not reading all the papers out there and things like that. So probably some more deep dive into some of the references that I've given might give you insights into if there are any benchmarks. Okay.
Is there any service available for labeling data in cybersecurity domain?
Yeah, so services are plenty. I mean, there are even I'm looking for some such service. If you come across, let me know as well. But there are numerous data labeling services. You can outsource it, and you could build. You could use something like Amazon Mechanical Turk kind of, where you can hire people. But what I would recommend is that, I know data labeling part is the painful one, but there is no shortcut there, because all your models that you build depend on the efficacy of your labeling, right? So even if it is painful, probably you pull a bunch of your friends, and then explain them and then label it and verify, because outsourcing data labeling will impact your results. That much I can say, because it's very difficult to get people who understand the domain and then label it appropriately.
Thank you,
Okay.
sir.
Yeah.
Good morning, Sashank sir.
Yeah.
Yeah, it's a very nice, very good presentation, sir.
Thank you.
So here my point is based on probability and impact, sir.
Uh-huh.
So what if the
Yeah.
probability of the risk is low, but it it creates lot impact.
Uh-huh.
So if it comes to the remote locations, like if I
Good
am
question.
handling, if I am having, sir, this is regarding probability and impact. So my
Correct.
point here is, if I want to build my own system, for instance cyber physical system, if I want to run that in a remote
Uh-huh.
location and in a physical environment as well. So
Okay.
according to my assessment, if the probability is very less but the impact is more,
Uh-huh.
so in that case what could be the solutions, and can we follow the traditional solutions, or we need to build up our own model or something like that?
Okay. So very, very good question, right? So the widely accepted definition of risk, right, in some sense, risk score or whatever you could think of, is a factor of the probability of the threat and impact. So you could simply take, let's say, impact is on a scale of 0 to 100, and you take a probability, right? And this score, you need to keep in mind that the score is only to prioritize. Like if you have 10 things to do, which one to go after, then you need to come up with probabilities of each of these and the impact of each of these, probability into impact, and then bring up a prioritized list. Then you can go after the ones that give you higher number. That's kind of widely accepted to give you better results. Okay, so in summary, you need to consider both the factors in order to prioritize a particular remediation. Does that help you answer the question in some form?
Yes, sir. But one
Yeah.
more in connecting to this, one more
Yeah.
point.
Uh-huh.
Sir, will it be applicable for all kinds of or all levels of applications, like small scale or medium scale, large scale?
Absolutely, absolutely, right? See, whether it is small scale or big scale or cyber physical system or a manufacturing company or a pharmaceutical company, the domain gives you the impact factor. Okay, how important that particular asset or that could likely cause, right? The context of the vulnerability and the threat factors and the exploit available, the malware campaigns available, will detect this probability of a threat. Okay? So you have to bring this together. So the same model can be applied anywhere.
Okay, okay,
Okay.
okay. Thank you, sir.
Yeah.
Shashank, there are some questions I will read from the
Sure.
chat.
Yeah. Yeah.
One of the question is, most of the threat intelligence provides some awareness on currently employed attack vectors rather than potential attack vectors expected in the future. So
Uh-huh.
how can we forecast attack vectors for future, or
Uh-huh.
is it possible to forecast? Like,
Okay. So good question. So here we are talking about. See, first let's understand the scope of threat intelligence, right? The scope of threat intelligence always is after the fact, right? If you remember the pyramid of pain that I've shown you, the hash values, the IP addresses, the domain names, the tools, the TTPs, and things like that, almost always researchers have found these things in the log traces, in the investigations that they have done, and the incidents they have handled, and then translating it. So it's almost always, post ante. Okay, that's why threat intelligence is again used to fuel it back to other environments so that you can try to detect it, right? But when it comes to, so this is different from what an attack vectors mean. Okay, so threat intelligence is just collection of this information. Now, when it comes to attack vectors, it depends upon, see, what is a vector, right? How will an attacker probably attack your system? Okay, so think of it as something like this. You have a website or a web application written. It's like your home, right? I mean, it's what are all the doors and windows exist through which somebody can come, right? For this web application, are there API interfaces? Are there user interfaces? Are there database interfaces? Are there third-party interfaces? Right? These are all the places where somebody can come and attack the system. So these are the attack vectors. Now, if you want to forecast attack vectors, so just don't worry about the threat intel for a moment. Okay, you worry about what are the interfaces available for that application. If you are building a Kubernetes application, if you are building a Docker-based application, a web application, or whatever is that piece of software. Think of the API interfaces or what are the interfaces that somebody can interact with that. So attack vectors will come out of that, right? So those two are different concepts. But of course, you can use the threat intel to understand how they're being exploited, but still attack vectors come from your interfaces of the application. Okay. So there is
one more question. Can you discuss about proactive threat intelligence?
Yeah. So again, it's a misnomer, I would say, to say a proactive threat intelligence, because there is no such thing as proactive threat intelligence. Especially, it again depends upon, of course, who you are. Are you threat intelligence creator or threat intelligence consumer, right? If you are an industry or a commercial vendor or an open source team that is producing the threat intelligence, then of course you can call it as proactive threat intelligence because you have observed in few APT attacks that these are the hash values that you want to tell. But if you are a threat intelligence consumer, there is nothing like, again, a proactive threat intelligence. You just need to wait for somebody to give you the threat intelligence. And of course, you can proactively apply, but you can't. Why I said misnomer is that you can't create up threat intelligence proactively. You can't imagine saying that, hey, this registry entry likely to be in a malware. No, that will be a huge noise generating machine. But of course, you can proactively apply the threat intelligence in your environment to mitigate the risk, but you can't proactively create a threat intelligence. Okay.
Shashank, one last thing that I would
Sure.
like to share. Like from past few days, we were also working on some identical domain with one of my scholars where we were crawling through a lot of web pages and looking for some IOCs, indicator of compromise, writing a lot of regular expressions and looking for IP hashes and all those. Then we understood that we miserably failed because presently most of these online reports, they don't reveal all these things. Instead, it is more or less a textual data
Correct.
we get. So then eventually we understood like there is a lot of NLP techniques that we need to understand these TTPs. So one question that I had is like, do we have some reference? So for example, there are many research scholars also and few faculty like me who are pursuing the research in this domain. So the question is like, do we have some reference where we can understand like this appears to be a TTP. This is the syntax of the TTP. Something like, do we have so that?
Yeah. So what I can say with the experience in this field is that it is very difficult for deriving TTPs from NLP. This extremely uphill task. right? See, TTP is something like you are reading the mind of an attacker. He's trying to do a lateral movement, then he's going to pivot in active directory, then he's going to do something, right? By reading a blog, by reading a textual information or a security advisory, no, unless your model is very much onto APT reports. If you just go to, I think Attack Matter also has this APT. Mandiant has these APT reports. Unless you just want to focus on those APT reports and then derive the TTPs using NLP techniques, if you are using in a generic sense, then I'm sorry, that's going to be that's simply not the way, because that doesn't have any of this information that you can extrapolate. But what you can derive from those security advisories and news blogs and things like that is the problems that I have mentioned. The risk intel you can derive. You can say which organization got impacted. You can derive which exploit they have used. You can derive what is the likely loss. You can derive whether there is a denial of service. Those kind of things you can extract. Okay? That will give you better results than deriving TTPs. That's highly challenging.
Thank you, Sashank, for a wonderful lecture, and always like it's full of knowledge when we speak to you. I know since past, like when I interact with you. So still, participants, if there are some questions, I can read for you. Maybe if you can type. Or you can unmute and you can ask. Maybe we can wait for a couple of minutes, and otherwise we will close the session.
Sure. Okay, so if there are none, if there are more, I'll be glad to
Yeah,
have.
one of my colleague is trying to type because she's not having a microphone. Maybe like
Okay, no problem. I can wait. No
one
worries.
last question, Shashank.
Sure.
Sir, meanwhile, I have one more question, sir.
Sure.
Yeah, thank you. Sir, I think, is it like a predefined one, like the method or a model, like we will it be a predefined, or we can run it during the runtime?
Very good question. See, in my experience, there are two ways of uh, detecting anything. Okay. Almost always, the predefined ones have given better results. Right. So predefined IPS rules, predefined WAF rules, rather than heuristic rules that are runtime using some ML models, because the field of applying ML in cybersecurity itself so nascent. Almost always it tend to be noisy and prone to false positives and things like that. But whereas it's a static signatures, it's like less prone to false positives. Of course, there will be false positives in WAF rules and IPS rules. There needs to be some tuning, but it is relatively better than a machine learning model based on my experience so far. I think there is a question.
Okay, thank you.
Yeah, Shashank, one last question. Like, can you mention about some algorithms for sharing threats in privacy preserving manner or some protocols?
Okay, that's a good question. So it's a broad question as well. I think there's one paper that I've written in the past. It's there in Archive as well on this topic. It depends on what is that sharing of threat. Is it a user sharing his browsing history with Google's safe browsing history, where you want to know whether your browsing history is compromised or not? So there the information is about the domain names, right? Then you need a certain particular algorithms or protocols, like probably a zero knowledge proof or a multi-party computation, right? So it depends on that particular. Of course, that question itself is a loaded question with so many things. So I would recommend going through the paper that we have written in the past that covers a lot of these scenarios and protocols and problems. But as an example, I could say that one example.
Thank you, Dr. Sashank, for such a wonderful talk and accepting our invitation and being a part of this 2-week International Winter School on Cyber Security and Threat Intelligence. And your lecture was full of knowledge
Thank you.
and very fundamental aspects you touched, and the 7 research problems, like all of us can further investigate and build some solutions. So I, on behalf of all participants who have gathered online and everybody from Department of Computer Application, wholeheartedly thank you for being part of this winter school.
Welcome.
Shashank, thank you. Thanks.
Thank you for the opportunity as well. Otherwise, it's been back of my mind to articulate all these problems, but this was the opportunity where I could quickly put my thoughts and come up with that. So thanks for the opportunity as well.
Thank you, Shashank. Bye. Take care.
Yeah, you too. Stay safe, everybody. Thank you so much for attending.
Bye. Bye.